Assalamu alaikum friends, in this video I will show you how to configure temperature in TIA portal v16 using PLC S7-1200 with move commands. How to use any move commands? We have to create new project here, create new project, and I will give the name it here temperature TEM temperature control tool with move commands. Move CMDS move commands, and then click it OK. How to means logic creation yani. First we discuss about temperature configuration that in previous lecture, and in this lecture we will discuss about how to use in the programs because of configuration and using different methods. First of all, we have to go add new device, and then select our PC S7-1200, and what's the family number of that CPU 12 DC relay, that one last one article, that version 4.0, that's I have. It took little time, and with examples, I will share with you some examples how we use in temperature and in fields. First of all, the CPU inside we have to select our temperature module. Herein you go to the signal boards. If you put an extension module, this will be separate device, and if you use it the CPU and it look like BD, that's you have to select here also. That signal boards inside you have analog input. This one A1. I have one module only. That's the AI1XRTD. That's model I have, and simply you can click and drop it here. Now your module is configured inside, and also if you like to go to the properties to see this module details, go to here downside, and here it is telling analog inputs that starting address 82 and address 81, and channel 0, that's the thermal resistor 4 wire PT 100 standard range, and it will show in Celsius and if you go to I address, this he already shows channel 0 this one, and channel address also he shows here IW80, because when you read this module, you have to select that data register IW80, put it down, and let's first, if you like to download this continuously, and click it download. Because Siemens, that start search. When your communication is completed, that green indications will be highlighted, and it will be shows your connections with CPU and PLC. It's now okay. Then click it load. It's compiling now your modules, and it will be create. Continue without sensorization. Inside the no action, can stop all, and then click load again. because it will erasing the another old program inside the PLC, and then it will be configures new program. Now finish. Your everything is now downloaded in this module, and just simply go to the program blocks and make one new OB. And when first time you go into the main OB organization block, you have to first choose your any bit here. When you say like when like to execution the start, you have to choose any bit. And secondly, you can choose one move command, math functions, and go in the move commands, and this I will put I0.0, and then next address I will choose IW80. Sorry, IW80. And there is any data registers you can use. MD20 I will use for reading the data register, because your temperature will become set at that point, and after it moves in the D20. Let's download first and see it's running proper or not. Make simulation on, and then you can see your, I will change the display in the decimal format, and this also I display change in decimal format. And now our thermocouple is showing at the temperature near around 256 Celsius degree, and if I give him little by hand pulse, in little I will give hot, now temperature is increasing. Yeah, that means our temperature sensor is working properly and it's showing us temperature. Now what next? How we can use this temperature in the program? Stop simulation, and first of all we will make some example with this temperature. We will start from MD20. For example, we need one fan like to be operate with any cooling tower or something, any with blower. We will first of take it here 1 hour input. I will take it here I0.2, and I will make it here comparator operations. First of all, I will choose that one less greater than command. Here I choose MD20 when my data registers with equal or greater than this MD20. For example, I will put 255. If it's greater than 255, why it's showing red? Because of we not choose any data, any which data we like to choose. When you use the comparing command, you have to choose first that data which data you like to store inside, and then next I will choose my one relay Q0.0, Q0.0. That for example we can think in this Q0.0 is our fan motor. I will replace this tag name for motor MOT or motor. This will give the name motor, and this we can give that actual temperature. A rename tag is CTUL actual TEMP temperature, and this we give it set only. And here we can put the rename tag start, start. And here what we are doing, I say when my I0.0 signal comes after my temperature, this set point from the HMI 255 reach the temperature 255, my Q0.0, my fan needs to be on. And if I say I will take it here one branch, and one more command I will take, that greater equal or greater than MD20 if greater than 270 270 my Q0.1 go to on. This motor 1, for example, this MOT or no, not the same, like we can replace Q0.1 first apply, and after the tag you can replace the name motor 2. Means, for example, we can making the speeds of the motor. Also you can use this Q0.0 as a link of the drive or something. If you using that drive inside, you make 3 steps or 4 steps, have speed adjustable motor. There you can use also with this contacts, yani these contacts you can use as speed, yani. And I will take one more row at the here, and I will put that branch, sorry, this one I will take one more branch, and here one more I will put that command of compare MD20 when increases after 300 choose ingredient my Q0.2 needs to go on. Or also you can choose it here. First we check this program and download into the PLC. And make it simulation now. Our now temperature is 255, for example. This display also I will change in decimal. This display also I will change in decimal, and this display also I will change in decimal. See, what's our set point? Our set point, first set point is 255. It's now ready to on, but why is not on the Q0.0? Because of our main signal I0.2 is still not on, and also this I0.0 is on. Our temperature is coming 255, and when I make it this I0.2 on, see, this is not 2, this is 2. See, now my I0.2 signal is ready, and my temperature is 255 is now equals, are this increased, that will be work Q0.0. See, upside that one 63, 64, 69, and here I decide when my temperature is more than 270, equal with 270 or greater than 270, my Q0.1 needs to go on. As see, when it goes down to the from 270 any temperature, it will be stopped automatically. And this third one also, I decide that when my temperature is 300, that Q0.2 needs to be on. I will make little more temperature give, and I increase the temperature. See, 80, 84, 6, 7, 9, 90, 98, 300 now. When it reaches at the 300 set point, my Q0.2 goes to on. As my temperature when goes down of 300, that first my Q0.2 will be automatically stopped. 310, 309, 8, 6. Slowly when temperatures going down, our Q0. As it's reached go down from 300, it will be stopped. See, now our Q0.2 is now stopped, and now this is more than 270. Our Q0.1 will be still on, and that one Q0.0 is also still on. See, when it goes down near around to at the set point 270, it will be go to close. It will be go to close. Now let's see 270 it's come back or not. We will try to give little cool, maybe with some water or something. I will give cooling to the sensor and see it will be fastly go back. If we have ice, it will be fast go down. It's increasing. '86. When we give cool, after it will be go back. It will be not going back because of sensor not going cool. Now it's going back. 270. See, now it goes back to 255, and when it's go less than 55, after Q0.0 will be also go to off. As temperature will be increased, after this all will be stopped. You can fix this also in system in building rooms, in exhaust systems, if you need to maintain the temperature, you can use this program also. Sometimes you need to be blower on, there is too much temperature, you like to exhaust, make it on off, you can use this program. Now our all system is stopped, you can save your energy. For example, some exhausts are running in the building, very heavy exhausts which are taking the too much load, high amperes, and electricity consumed. You can use as per this commands and this program with exhaust systems. And when your temperature is normal, your fans will be closed. Or if the speed is like to be controlled, means if your temperature near around 255 equal or greater than 255, your one speed will be run slow running. If temperature goes to little high, you need to be second speed little go more up. And if it's more high temperature is coming, you can use the third number speed of the motor. And also this, if this data you like to see on the HMI, how much my temperature is running, you can take this data register MD20 at the HMI. And also if you need the set points for the speeds, simply go back to the program, simulation stop, and here we can use the, here we can one main new block. When we make it be one data block, and you can give it here the name EMP temperature CONT control, then click OK, and simply you can write it here temperature, temperature underscore 1. Secondly, temperature underscore 2, also temperature underscore 3, and this you can give the data types here. Also you can de-enter which data you like to use. I will choose the de-int or dword. I will choose this one, dword. Also this you can dword, and simply go back, and here you can write your data register. That you go to this, that global db1, can put it temperature 1. Secondly, you can choose that in temperature controller temperature 2, and simply third one also you can choose the temperature control data register temperature 3, and then again download to the PLC. Click load. Zero errors, zero warning. Make it simulation. And see, now our temperature is 251. Our set point here still not show. We will change that display format. We will put in decimal. And this also we will put in, we will put this display in decimal. This format also we will put in decimal. And see why it's all are on, because of we're not giving any value at the set point. How much temperature we require for to start this one, first one, here is not any value. Go to the simply here in dword, and you put in decimal. You love much like 255. I will put at the first. Now real temperature is running 254 and our set point is 255 and it will be stopped. And here also you can use that data. This I put 270 because of when temperature reaches at the 270 must be this Q0 dot 1 needs to be on, and this also we can put the decimal in 300. Any temperature you can write it at this command in the HMI. Now you can control from the HMI also, and when you take this one MD25, your actual temperature also will be shown at HMI. Now my first one is on because of my temperature is now equal with 255. When it's little go down, 1 point go down, it will be stopped. I try to little more try to make it down, but it's not good. See, now it's go down. And one more thing, if you need to using that one speed only and temperature you needs the different, you can make it here. Simply go back and simply you can give it here one close contact. Here you can give Q0.1 close contact here. When this one on, this must be on, off, and this one also you can put it one here Q0.0, and here also you can put one close contact of the Q0.1 and Q0.0. If these both are on, this your temperature will, this coil no need to be go on. And again download to the PLC, then click load, make it simulation on, and see, now my temperature is set point is 255 and our real temperature is coming 244. I try to give this temperature little more high. See, as temperature comes at the set point, our Q0.0 is energized, and when this temperature reaches at the 270, our Q0.1 will be on and that Q0.0 will be stopped. I will give little more temperature. See, now it's increases than 270, 82, but this our Q0.1 is not on because of this our Q0.0 is on. And why this is not on? Because of this set point we put at the 255, but this temperature is not less than 255, it's more than 255. So that's the what we can do. We can go back, stop the simulation, and here we can put one more command. One more command we can take that in this command MD25, and that you can give this dent data, and that we will put 255 for example. Less than 255, this have to be go on. Let's start simulation first, this one. Next we will check what's happening. That examples you can make in the program logic. When you create the logic, you can choose that sim like any how we can design the program, where we and any command like to use. This we put that less than 255, also this goes to on yani. Now our temperature is 266, but if this go to less than also 255, we will see what's the happen. Oh, one mistake we made. We use this data register wrong. MD25. We have to be this use same data register, because of this we are reading the temperature at MD20. MD20 we are using the data register, and then again download. Click load and make the simulation on. Now what's happening? This temperature is less than 255. When it's less than 255, it will be not start. We will give little more temperature. If what is do, when it is more than 55, that will be also not on. See, because of we give the command him when this temperature is less than 255, less than 255, this Q0.0 needs to be go off, and this we put how much? This 270. Now our 266. We will give a little more temperature. See, now if more than 270, that our Q0.1 will be on. This we command, and we decided here when Q0.0 is not on, after this our Q0.1 goes to be on. This now our temperature is now 288, but this will be on Q0.1, and this we put at 300. When this both are not on, after this we decide this one Q0.2 goes to be on. 280 is temperature. We put this one more. We will reach at the 300, and what we see. See, now our temperature is up than 300, but our Q0.2 is not on. Because of this we decide 270. If more than 270, this must be have to goes to on. So what to do? We will stop the simulation and we will change the logic. Here this we will delete this one. Also this one we can delete. This also we can delete. This also we can delete. And this also we will delete. And what we choose, we will decide it here. If our this one less than this temperature 1 means this we set point put for 255, and if this less than 255, this will be on, and this also we will go to here. If this is also less than 255, this also goes to be on. Let's download and check. Make it the simulation on. See, now we decided here, if our temperature is more than 255, our Q0.0 needs to be go on. And here we decide our if first I will give the in decimal, and this one also format in decimal. In decimal, and this I will also put in decimal. Here we have to go, and this format also I will change to decimal. See, now our three are all are on because of what we decide. We decide if our temperature is more than 255, our Q0.0 needs to go on. And here what we decide, our temperature is less than 270. After Q0.1 goes to on. But we need to be reduced 200 in decimal. We will put it here 255. When less than 255, this Q0.1 needs to be go off. And this also we put 300. If less than 300, after our Q0.2 goes to be off. If I let's change it here in decimal, 255. If I put less than 255, that goes to be stop. So same as you can use this commands, and also you move this data to another areas also. And one more settings I will show you. If you like to different yani mix, then for example you say one motor is another area and one motor is another area, and you give the simple command from another different areas. You can this one delete this row, and now this all are totally different. And here we can decide that one, this is greater than, this is greater than, this is also less than. Okay, this will we will be used at less than, this is better yani. This is different, and this way use at I0.2. And here one we will use that division command. We will use it here. When I like to tell you how to use the division command in the TIA portal. For example, real temperature like to showing, you have to use the command in division command. Math functions, conversion. In math functions you can use that division. That division command we will use for real temperature. Here we can use that MD20, and this I will give MD30, and I will take the answer in MD40. MD40, and this also I will use MD40. This also I will use MD40. And this also I will use MD40. Why this is MD40 is showing wrong tag? Temperature 1, temperature 2, temperature 3. Because of this we first using that data registers MD40, and this program I will download to the this we use the UD this we will change little after that auto and D int we have to be used, not UD int. Again download, load, and make it simulation on. In this format I will make in decimal, and see now our showing is temperature 253, and how much I will divide it here. For example, I will divide it here for 25. It's how much answer coming 10, but our temperature is 25, but I will put it here 35. If here, no, not 35, we can put it here 20. If we put, this is your 12 coming. If we put divide by 10, it will be coming your 25 temperature, and that's your real temperature 25. You can put in the 25. This also you can put it here 25 hexadecimal 25. This you can also display, you can change in format. This display also you can here click, after go to the decimal, this all are decimal. That set point 255 is from where coming? Because of this set point we changed. Here we have to be changed that data register. Data register will not change. That's he is showing it here, this 255, but that's 25. That's accurate working. This coming actual temperature 1 25, because this MD40 we will use. See, it will be divided, and after put it in next row. See, this is 28 now, 29. When it's going to 300, it will be shows the 300 temperature, and 31 shows 32. this data registers are wrong. This is not that same MD40. This is we use old data registers. If we like to make it correction, go back and your temperature control data dword. That's showing now. We make it new, no problem. Because of when that's showing, this we complete delete, no problem. Because we make it division command and we will check only this one. MD40 and here we choose that here data we will make first. When go the temperature dB, this dB T1 T2 T3 and that data registers we will choose word also word, that also word, and that we're using word. Here we use this one D word. Here we temperature control T1, that's only one we will use. And this why showing red this one, because of this data we will choose word, and here we're using that the int. Int d int real word string character long real d int, but this also if we use this d int, the time MD40 will be not accept. This data register will have to be changed this another MD40 UD int. UD int if we choose that one, it will maybe show. Download the here, reinitialize and then click OK. Make the simulation and here we put in decimal 27. See, our temperature is now how much coming? 25. Real is coming bits. This is bits are coming 255, and 255 we make it division in division command, multiply with make division with 10. Our answer is 25, and we put this one 27. If our temperature is equal or greater than 27, after our Q0.0 needs to be go on. We will give little more temperature to increase our temperature. This 26 C. As our temperature will be reached at the 28-25, it will be goes on that Q0.0, and when it's good reduce, after that will be stop this Q0.0. In many of data registers you like to move, for example, they stop this one execution and that's you hear it. Delete this one and this also delete, so also delete, and see in one row I will show you to you better understand. Here for example, here I will move this move command, move operations, that move MD40 like to move MD50, and then again download to the PLC. And then make it simulation on. See, now first bits when we take that real temperature, our is coming at MD20. When MD20 we multiply with division with 10, our answer will be 26. And when 26 is coming at MD40, we change that our move this data to the MD50. And why this move this data to MD50? Because of somewhere if you like to use the some switches, more switches you like to make when 26 temperature need to be moved and Q0.0 need to be on, or Q0.1 need to be on, or how many any you like should data change any. For example, in any program when you making too many programs in the one program, after you can use this data registers, how many times you like to change this data registers, you can change. And in front of this one, any first of command you can move that. Here can put any, for example one more we will use it here, one more we will move it, choose it here, and one more move command, and I say when my MD40 is MD60, like to transfer an MD60, and here I put one contact, and here also I put one contact, for example M0.0, M1.0, and make it download to the PLC. Click load, and make simulation on. See this this M0.0 is not on, and our temperature is how much? 25. When I increase this temperature, your temperature is running now, for example 26, 27 now, but here your temperature will be not move forward. As you make this on, your temperature will be moved to the another. Because of this, many of areas you can put this switch. For example, this when mold is opening and some switch is on, you say that time this temperature I like to be move this area. And when you like to see this one, here also see that's now temperature is 29. You like to be when this switch is on, after my temperature will execute. If I not make this switches on, my temperature no need to be execute. When as I make it this on, your temperature will be forward. And where you will stop this execution, your temperature of increasing, but this will be not move. See now 28, 29, 30, but this is moving, this is still at 27. This will be not move, and your compare command will be not energize your next command. As I make it this one on, it will be moved. Why this data registers to use in the PLC and various, maybe you 100 data you can use, and you think from one switch, when my switch is ready, after this temperature move on, otherwise my temperature not show or not any execution next make when the switch is on, after my temperature is execute, otherwise not execute. Some heaters or whatever, or blowers and cooling towers, many areas you can use this commands. So I think so today will be more I can explain you in this lecture will be too much long. I hope you understand about the temperature, how we can monitor and how we move in, and how we make it division, and how we can make the compare. All about you understand. If you not understand anything, you can send me message in comment section or send me email. I will give you reply as soon as possible. Thanks for watching.